Okay, so hello everyone. Thank you for attending the webinar. Today we are going to see the new quarterly updates from the last quarter. So first of all, let me present myself. So I'm Bernardino Martin. I'm part of the product team. I'm working as a product owner, specifically in the part of the PV plant. So I'm focused on the requirements of the feature of the software for the PV plant. And yeah, today we are going to see the last updates from this last quarter. We will start first seeing the new tilt angle batch mode. So basically we can run the different designs changing the tilt angle. Then we will see how to customize our transformers for the power stations, changing the number of windings, number of transformers, short circuit current, and so on. Then we will check the new interface. We'll see how it works and how to iterate faster. Then I will show you the comparison tool. Most of you already know how it works, but now you can export all the results of the comparison to Excel, so you can create your own plots. Then we will see in ACBES how to rotate the layout. We will create also in our site, using the interactive site creation tool, some predefined geometries, for example, squares or circles. Then I will show you the new Arena CapEx templates that we have just uploaded to our software. And last but not least, we will see the DC couple best function. This is the last feature that we launched, and it was yesterday. So let's start with July. The first tool was that we launched this quarter was the tilt angle batch mode. So basically, now you can define the different tilt angles and generate different designs at the same time, and to compare them later. Okay, there are different ways to do this. You can do it fixing the pitch distance or making it variable. Let me show you in PVDesign directly how to do it. Okay, so here we have PVDesign with a base case that I have already created. So if we clone this design, we can see the already results. This is the new interface. We'll see it later in detail. But for now, let me show you how to run a batch design. So you just have to click this arrow and click on Run Batch. Here you can define different pitch distances and different DCC ratios to run designs. But also now you can also define different tilt angles. And when we change the tilt angle, we can decide if we want to fix the pitch distance so it doesn't change with every iteration, or if we define a different pitch distance for every iteration. So here we have a default value that is based on our recommendation. This recommendation depends on the latitude of the site and also on the tilt angle. So if you have basically we take the shading angle limit in the winter solstice, ensuring that we have at least 4 hours of generation without shading. And basically that's the requirement that we use. But if we set a fixed pitch distance, we can, for example, set a tilt angle of 3 degrees at minimum, a step value of 3, and reach up to 30 degrees tilt angle, fixing the pitch distance, and we can refresh the data table and generate all the designs at the same time. We can see now that here on the right side of the screen, we have our design history and all the designs are being generated. Okay, and yeah, I will show you later how to check them individually, how to save them, and how to compare them once we are working with the interface. Okay, let me go back to the presentation. So here we can see how to customize the power station transformers. Now in PVDesign, you can define the number of windings per transformer, 2 or 3 windings transformers. And you can also define if you want to have 1 or 2 power stations, 2 transformers per power stations. You can also oversize a bit the capacity of the transformers by setting a different value than the sum of the power of the inverters. And you can also define a short circuit impedance for the power station. Okay, all these results will appear in the SLDs, as you can see here. We have a 3-winding transformer, also in some documents as the design report in the tables. You will see it also the difference in the bill of quantities and in the project sheet. If you have doubts later, we can see in detail how to do it. But basically, let me show you fast. You have to go to the equipment tab, go to power station, and here you can define the different power stations. In this case, we have just one power station because we have selected only one inverter, but if you select 2, for example, you can define a primary and a secondary power station, and you can define everything, all the values that we saw already. Going back to the presentation, here the next feature is the new interface. Let me show you how does it work. So if we go back to our base case, here we can see on the left side all the inputs of the design. Okay, so this left side is the inputs part, so you can choose the different tabs to set the different inputs. Then here we have on the top part of the screen, we have all the different views that we have available during the design process. This first one is like a preliminary view, the preview view, where we can see the installed structures and the ones that are going to be removed. And also we have the other view, that is the overview view, where we can see more details. For example, the power stations, the medium voltage cables. We can also enable the trenches and the string cables and more details. Okay. Then we have the 3D view, where we can see in this map how to see the topography and the structures in 3D. In this case, for example, we are checking the one of a 0-degree tilt angle. If we go, for example, to the one of 10 tilt degree, we can see directly how it changes. So it's really fast to change views and iterate between designs. Okay. Also, once we have our designs generated, we are able to save them. We can save one by one, clicking here on save, or we can select all of them and save them all at the same time. Okay, as I have just done. Also, something that I didn't show you before, here we can see the different results. For example, this one with the highest tilt has a performance ratio of 81. And if I go, for example, to another one with another tilt, we can see the other performance ratio here. Also, the inputs change when we change from one design to the other, so we can always see the original inputs here. For example, we were changing the tilt angle, so we can see that this design is the one with a 12-degree tilt angle, or to this one with a 30-degree tilt angle. And just if you want to iterate based on this design, you just need to change one input. For example, let's change this to 40, and you will receive this message where the results are not updated, and you can run the design again. Okay, let's run it just to test it and to see how it works. Also, the views will start loading as they are generated, but you can always keep iterating. We don't need to wait until the design is done to keep iterating. Okay, let's go back to the presentation. Here we can see also the comparison tool, how to export them. So as you saw, I already saved the designs, so that's the first step to compare designs. So if I go back to the project tab, so inside the project, we can see the different designs that we have saved already, and we can select them. In this case, we have 11 designs and compare them. Okay. So here we have the comparison. This is something that It's not new in PVdesign, but what is new is the option to export. So let me just sort, just to see the results. Let me sort the designs by tilt. Okay. So here we can see the one of 0 tilt, 3, 6, and so on. And we can find, for example, based on the LCOE, the optimum one for us is the K6 with a 15 degrees tilt angle. Okay, that's for a 7 meters pitch and for this specific latitude. So I will save it as favorite just for the example. Okay, then let's export these results. So we can download the comparison in Excel. And also there's another option that we can download the charts. Okay, so here we can see different charts where we can see the monthly production of energy, the capex. In this case, as we have the same peak power in all the designs, is constant, the LCOE, and other values. Okay, let me download also this one. So here we can see the table that we already downloaded. So here we can create our own plots, do our own analysis based on all the results of all the designs. So this will help us to be more to have a more custom comparison, let's say. So as you can create your own plots in Excel. And let me also download the charts report. So here we have the other example that we can download, but basically are the charts that we saw in PVdesign. Okay. Let's go back to the presentation. Okay. So here we can see the shape tool. I will show you now how to use it, but basically this is inside the interactive site creation tool. So let me go back to the design. So we'll take the base case. Okay. And let's imagine that we are working on our design, and then we discover that there are some restricted areas, some trees that were not considered in the site, and also we need to add another area for a battery storage area. So we are going to location. We can clone the site to the site, and here now in polygons, instead of adding a free shape polygon, we can define, for example, some already predefined shapes. So we'll go for battery area, and I will create a rectangle. So I want to create a battery area here, parallel to the perimeter of the site. So you have just to add 2 points, and then select the direction and the last point here. We can also define the MV point for the medium voltage cable for the battery area. And I will also add, for example, some restricted areas using circles, okay? So here we have some trees. Let's suppose that I want to add these trees here, just to delete the structures that are on top of those trees, okay? Let me add another circle here, for example, okay? So as add it as a available area, we'll change it to restricted area, and done, okay? So I will save this site to keep working later, okay? Best area. Let's go back to the presentation. The next slide talks. So here we can see the best rotation angle. This is also something new. And before, we used to have a fixed rotation angle based on our recommended value. Now you can define different options. So let's go back to PVdesign. If we go here to the best tab, we'll zoom in the battery area, and here in best layout, you can define the battery placement. Okay, in this case, let me run the design. It will place the batteries based on our recommended value. We try to look for the best angle to maximize the the install capacity in the area. But if we want to set a different angle, for example, let's suppose that we want to have just one battery container, one power conversion station, and we want to have it parallel to the power stations and so on. So we can use the horizontal position and just run the design again. Let me change to the overview view so we can see also the fence and the power stations in the site. So in this case, is a more simple case. You can also place them vertical if you want, or you can also define an angle. So let me, for example, define here 20 degrees. So as you can see, with the new interface, it's really easy to iterate, and you can easily change from one design to other to see the differences. And you don't need to wait until the design is done, completely done, to see some results. Okay, let's go back to the presentation again. Here we can see now the last updates. We have updated our database, CAPEX database. So now you can select the new IRENA templates based on their last report. And also we have set those templates as default. So when you start designing some of the countries where IRENA have done there is the study, their CAPEX templates will be selected by default. Okay, so for example, here in this case, in this project, we are working in Brazil. It's Minas Gerais, a state of Brazil. So if we go to CAPEX, we can see that the Brazil CAPEX template have been selected by default. Okay. Let's go to the last case, to the last update. So here we have the DC couple BESS system. So this is this update was released yesterday, and here we will see how to design a DC couple BESS. So in this first design, this last design that we did, we were using AC BESS. So basically the batteries are contained directly to the substation or the switch and breaking station, and they have the batteries have their own transformers and their own inverters. Okay. But if we change the type to DC BESS, for example, and here we can define also the equipment. So we can define, for example, the number of DC-DC converters. Let's choose, for example, 100, the power of the DC-DC converter to be 100, and we want to have 10 DC-DC converters. So in this case, we have a base AC ratio of 0.5, and this means that the best power, so the power, the converter power that is 1.5 megawatts, is half of the inverter power. Okay, so as you remember, in equipment, we choose one inverter per power station, and this inverter has a power of 3 megawatts. So in this case, we have half of the power in converters. Okay, so the best AC ratio is 0.5. Then the design is not updated. Then we have the battery containers. This is the same as in AC BESS. You define the size, the capacity of the battery containers, and here we can define the requirements. So we can define if we want to install as the maximum amount of batteries, or if we want to define one. In this case, we will have only one power station, so both solutions will give the same result. And here we can define the supply cycle duration. So basically, how many containers do we want to have per per power station? So if we choose 2.6, we'll have 2 battery containers for that design. Let me run the design again. So now here we can see that we have the power station with the 2 battery containers, and the AC BESS area is empty as we choose the other solution. Okay. Also, the AC BESS is not mandatory. That's important. So we don't have to create this area anymore to use it. Okay. Here in the BESS layout, we can define some distances between containers. If we are, in this case, it's a design without roads, but if we have roads, you can also define some distances from container to road and so on, okay? Let me save this design to see the results. So if we go back to the project design, here we can see inside all the documents where we can see that we have some best design report. So this report will be focused on the DC best solution. And we can see here the main equipment and an explanation of our design with the converters and so on, okay? Then we can see also in the SLDs, for example, I will take the medium and low voltage ones. Here we can see in the same inverter how we have connected the 10 converters, okay, with their battery racks. And here we have the string boxes with the PV modules, okay, and the strings. So all the equipment is being connected to the same inverter. This is also an advantage compared to AC BESS, that we are having only one transformers instead of two. Compare like before we had two, and in this case we have only one, and also one inverter only instead of two inverters or more. Okay. Then also these other results are the bill of quantities, where we can see we have a tab dedicated to the DC BESS. So here we can see DC BESS system bill of quantities. We can see all the quantities. Going back to the presentation, yes, we also updated our methodology. So when we create a new methodology based on the AC and DC BESS, and you can also check the knowledge base articles for more details. Okay. So that's it. Those were our updates from this last month and the last quarter. And so feel free to ask questions so we can check them. Okay, I think we don't have, yes, we have questions. Let me open them. Okay, someone is asking if we have the CapEx templates available in euros. No, for now, no. So Irina, we have, so you can, let me show you, Vera. You can create the, okay, let me open PDesign here. You can create your own CapEx templates in the CapEx tab here. You can, for example, clone the one. Let me go to public templates, the one that was using in Brazil of 2022. I can take it and clone it and change the currency to euros and convert these values to the current conversion rate, for example. And you can also choose between different currencies, but the default ones that we have from Irina are based on dollars. We don't have them available in euros, okay? But you can always change the currency. Then we have other questions here. Okay, so yeah, I think they are asking if the DC BESS layout in the VCDS layout PDesign places the containers in the BESS area, or if it's possible to place them next to the power conversion stations. So in this case, as I showed already, I don't know if you follow the presentation or if I'm not understanding well the question. Maybe this was asked before. You can decide whether to put them close to the power stations, as we saw here, or if they are placed in the battery area, okay? So in this case, we have them, the batteries here, close to the power station, and we don't need to create this area anymore, okay? Yeah, I don't know if I understood your question. If not, feel free to send us an email and we can check it in detail. Okay. Let's wait one or 2 minutes more to see if anyone have questions. No more questions? Yes, we have another question. In the energy results, I only get the year as 1990. Okay, so basically, yeah, let me show you, sorry, let me show you the energy results. So here, when we download the energy yield results, we get them based on 1 year only. This year is the, let me open it. So if we go here to early production, we see that we are using always the same date and hour, but here you can see the different years of simulation, okay? When we simulate in PVDesign, we are using a TMY file that is a typical meteorological year, and we use this year by default for all the sun angles and everything. So so this date is not, let's say, the real date of the metadata file, okay? So when you upload a file to PVDesign, it's a TMY file, and this is the reference year, but it's not the year of the data, okay? And here you can see the difference between years are basically the degradation and so on, as we are using always the same meteo file every year. Only the equipment is being degraded and the losses change a bit from year to year, so you can see that the generation is being reduced year after year, okay? We have other question here. Are there available CapEx for the substation too? That's a really good question. So we don't have a default CapEx templates for substations for now, but this is something that we're considering for the future. And also we want to add more units. So for example, if we go here to this template, I will clone it to check it. And here we have different units based on the bill of quantities of the PV plant. But I'm not I think we are not taking some of the units of the substation. So it will be interesting for the future to add them to calculate the capex for the substation too. But for now, we are not working with that. Also, we are not including the prices of the energy storage systems, but we are thinking on how to do it in the future. Thank you very much for the question and for the feedback. Okay, I think I have already answered all the questions. I will wait a bit more. Okay, so I think we can leave it here. Thank you very much for attending the webinar. I hope to see you in the future in other webinars. And that's it. Thank you very much. Bye.